In this video, we are going to look at covalent bonding. Now, here, the type of bonding that we are looking at, we are trying to look at the bonding or the bond that is formed when there is a share of a pair of electrons. So, we are saying if we have two atoms, we have this atom and also we have another atom, so we can call the first one as atom A, then the second one we can call it atom B. So we say atom A is a nonmetal, also atom B. So we are looking at now what happens if two nonmetals combine together. So here, the nature of a nonmetal, the nonmetal has the ability to gain electrons, and also so atom B has the ability to gain, so is atom A. So even this one has the ability to gain. Now, if these two are trying to react, so what they do is the atom A will contribute maybe one or two electrons, and also atom B will contribute as long as the two elements attain the stability. So here we can put this in dots as the electrons for atom A and the cross one for electrons for atom B. So what we are saying is the covalent bonding is formed when two nonmetals combine together. So since the two nonmetals, they all have the ability to gain electrons, none of the two has the ability to give electron or electrons. So what they do is they need to make an agreement where they have to share the pair of electrons. So covalent bonding, it is just the type of bonding that involves the sharing of electrons. Then also we need to know that this covalent bonding occurs between nonmetals. Okay, then from there, this bond, the attraction between atom A and atom B, this is what we call a covalent bond. So the bond is known as the covalent bond. Then the process by which the bond is formed is what we are calling as the bonding, which is covalent bonding. Now, the whole thing, this substance that consists of element A and B, this is now what we call a covalent compound. So the compound is what we are having is like the product. So what we are getting after two or more nonmetals combine is what we call the covalent compound. Then the bond is known as covalent bonding. Then the process by which the bond is formed is what we call covalent bonding. Now, let's look at examples. Okay, so now we want to show using a dot and cross diagram how atoms are bonded in the first one, methane. So the chemical formula for methane is CH4, or if you want we can form it by using the valences. So carbon is in group 4, so it has a valence of 4. Hydrogen has a valence of 1. So if we swap the numbers, we can see that the chemical formula for methane is CH4. So one atom of carbon needs 4 atoms of hydrogen to share in order to attain the stability. Now, the carbon atom has a mass number of 12 and the atomic number of 6. So if we form the electronic configuration, we can have 2, 4, where the first shell we need to put 2 electrons, then the outermost shell, which is the second shell, we are going to have 4 electrons. So we can see that the carbon needs 4 more electrons for the second shell to be filled. Now for hydrogen, hydrogen has a mass number approximation of 1 and the atomic number of 1. So you can see that the outermost shell, which is one shell for hydrogen, has 1 electron and it needs also 1 electron to be stable. So each hydrogen needs 1 electron to be stable. Now, away from there, we said that carbon is in group 4. So elements in group 4 has 4 as a valence number. Then also we need to know that they tend to make 4 bonds. So we are expecting to have 4 bonds. So the valence number can be used to determine the number of bonds a particular element makes. So this is the picture that we are trying to have in mind before we look at the diagram. So we can see that we are going to have hydrogen there, also hydrogen there, hydrogen, and also hydrogen. So the other thing that you need to know, each bond here, each bond consists of 2 electrons. So there are 2 electrons for each bonds. So if we can calculate by multiplying 2 electrons times the 4 bonds, we can now see that their carbon is satisfied by having 8 electrons. Now under this bond, or under each bond, there is 1 electron coming from the carbon and the other 1 electron coming from the hydrogen. So the picture we have, we just look at one. We have this carbon has 1 electron, then also we have this hydrogen where there is this. So this will come here and also this will come, they are forming a bond. So that is the picture that we are trying to portray. Then the other thing that we can know about this is for elements like carbon where we have 2 shells. Let me first draw. So carbon, we have 2 shells. The first shell and this second shell. Okay, so now we know that the first shell of carbon will have the first 2 electrons here. Then we can see that in the outermost shell of carbon, we are going to have 4 electrons. So here we have 4 electrons. Now from there, the other step or thing that you need to know is the electrons that are found on the outermost shell are known as the valence electrons. Then those that are found in maybe, as long as that shell is not on the outer part, like for carbon, the shell number 1, this shell number 1 consists of the electrons that we call the co-electrons. So these are known as the co-electrons. So here we have 2 co-electrons that are found on the first shell. Then the valence electrons are the electrons that are involved in bonding. So here we can have now hydrogen. So hydrogen, we have hydrogen. This hydrogen has 1 electron. So this one must go there so that this hydrogen will have 2. Then we have another hydrogen here with 1 electron. This will share with this one. Also here, this will share with this one. Then the last one will share with this one. So you can see what happens. So let's now finish our diagram. So our actual diagram will be like this. Okay, so now we have each hydrogen is donating 1 electron, and here we are going to have the other 1 electron coming from the carbon. So this is how we can draw the covalent bonding in methane. So we can see that for carbon now, the outermost shell for carbon, which is the second shell here, we have the 8 electrons. So the carbon is satisfied, and each hydrogen has 2 electrons. Okay, let's have another example. Okay, this time let's say we have water. Let's have water. The chemical formula for water is H2O, where the oxygen has the mass number of 6 and the atomic number of 8. Remember, whenever we are dealing with bonding, we always use the atomic number. So the first shell of oxygen will occupy the 2 electrons, then the outermost shell will have the 6 electrons. Then for hydrogen, so now for oxygen, it has the valence of 2. So we have the valence of 2. Then hydrogen, always hydrogen forms a single bond. So we are going to have this single bond and also this single bond. So this is the picture of how this molecule will look like. So let's first draw the central atom. So in our case, we'll consider oxygen to be the central atom. Okay, then we will put the hydrogen. So we have this hydrogen here and also hydrogen here. So in total, if what we can add the electrons that we have, we can add the electrons that we have for water. So we can see that oxygen has 8 electrons plus 2 electrons from the 2 atoms of hydrogen. So in total, we have 10 electrons. So from the 10 electrons, let's first fill the first shell of oxygen. So we have 8 electrons remaining. Now for hydrogen, we know that hydrogen forms a bond with 2 electrons. So here we are going to have 4. So the 4 electrons are being shared between the 2 hydrogen and the oxygen. So from the 8, if we subtract the 4 electrons, we are going to have 4 electrons remaining. So the other 4 electrons, we are just going to put them here. So as we can see, our oxygen, the second shell of oxygen has 8 electrons. So this one is now satisfied. Then the other shell for hydrogen and oxygen, we have 2 electrons. So this is the covalent bonding for water. Let's try another one. This time let's try methane. Let's look at the ammonia. So ammonia consists of nitrogen. Nitrogen has a valence of 3 since it is in group 5. Then hydrogen, we know it's 1. So if we swap the numbers, the chemical formula for ammonia is NH3. Then for the mass number of nitrogen is 14. The atomic number is 7. So the first shell will have 2 electrons. The outermost shell for ammonia, we are going to have 5 electrons. So let's have the central atom, which is nitrogen. Okay, so now let's look at how many atoms of hydrogen do we have. So we have 3 atoms of hydrogen. So let's say we put one here. At least we know the picture for hydrogen. So the bond between hydrogen and the other element must always have 2 electrons. Then 1 electron will come from the hydrogen, then the other electron must come from the other element. So in our case is nitrogen. So nitrogen has 7 electrons plus the 3 electrons from the 3 hydrogen. So in total we have 10 electrons. The first shell for nitrogen will occupy the 2 electrons where we have now 3. So 8 minus 2, we have 8. 10 minus 2, we have 8 remaining. Then here we are going to have 1 atom, 1 electron from hydrogen, 1 electron from each hydrogen. Then also 1 electron from nitrogen, and also 1 electron from each nitrogen. So we can see that we have now 6 plus the 2 from the first shell, 8. If we subtract 8 from 10, we have 2 electrons remaining. So that is the compound for ammonia. Okay, let's have another example. This time let's look at carbon dioxide. Okay, so now carbon dioxide. So the chemical formula for carbon dioxide is CO2. We can form by carbon has a valence of 4, oxygen has a valence of 2. So we can see that we have even numbers, so we can reduce. So 2 into 2 is 1, 2 into 4 is 2. So if we swap the numbers, this is how the carbon dioxide, the CO2, came into existence. So under carbon dioxide, we are looking at a compound where 2 atoms of oxygen bonds with 1 atom of carbon. Then we know the carbon has 6 electrons. First shell 2, the second one 4. Then oxygen has 8. Where the first shell is 2, then the other shell is 6. So in total we can see that we have so 8 times 2 is 16 plus 6, that is 22. So in total we have 22 electrons. So let's first begin by writing the central atom, which is carbon in our case. Then here we are going to have our oxygen. Okay, now let's have this picture. So carbon forms 4 bonds. So we are expecting 2 bonds in between carbon and oxygen. So this is the picture that we have. So the reason why I'm trying to use this format is to have a picture of how many electrons will be shared between the two atoms. So since we have 2 bonds in between here, so what this means is we need to have 4 electrons that will be shared. So that is the picture. So if there is 1 bond, it means there will be 2 electrons being shared. So what you are saying is this. So first let's begin by indicating. So from the 22, first we have 2 electrons in the first shell of carbon and 2 electrons in the first shell of each atom of oxygen. So we can see that we have subtracted 6. So we have 16 remaining. Now we already have the picture. So carbon will contribute 2 electrons on each bond. So here we are going to have 2 electrons from carbon on each bond, and also we are going to have here we are going to have these 2 electrons from each oxygen atom. So for carbon, we can see that carbon is now satisfied because we have 80 electrons. Now each oxygen atom has 4 electrons, so there is 4 more remaining. So here we are going to have 2, and also here 2. Then so we can see that now each atom is satisfied. So under oxygen we have 8 electrons in its outermost shell, and also carbon has 8 electrons in its outermost shell. So in total we can count. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So this is the compound, which is a covalent compound for carbon dioxide. So this is how we can draw a dot and cross diagram if we want to show how atoms are bonded in a covalent compound. So that's it for this video. If you have questions or maybe the topics that you would want me to look at, you can leave your comments in the comment section below. So that's it for this video. Thanks for watching, and don't forget to subscribe.